So we're going to look at these things called molecular and formula masses, right? So we already have looked at the atomic mass. Remember, the atomic mass was the average mass of all stable isotopes, and you use the abundance and the mass of each isotope to come up with the atomic mass. So molecular mass and formula mass are going to be the mass of molecules, or are going to be the mass of compounds. Molecular mass is going to be the mass of covalently bonded compounds, and formula mass is going to be the mass of a formula unit of an ionic compound. Remember, ionic compounds are these big crystals, and we use the lowest possible ratio of ions as the formula, and we call that lowest possible ratio of ions a formula unit. So formula mass is the mass of a formula unit. Right, so what we've got here is, now instead of just doing atomic mass, we're going to be able to determine the masses of, molecules like H2O or glucose, C6H12O6, or of a formula unit of an ionic compound, MgCl2, so magnesium chloride. So to do this, it's pretty simple. We look at the formula, we get the atomic mass for each element in the formula, we multiply the atomic mass of each element by the number of atoms of that element there are, and we add them all up. For example, for water, we know there's 2 hydrogens and 1 oxygen. So there's 2 hydrogen atoms and 1 oxygen atom. So that means we're going to need the atomic mass of hydrogen and the atomic mass of oxygen. So if we look on the periodic table, the atomic mass of hydrogen is 1.008 AMU. Remember, those were atomic mass units. And the atomic mass of oxygen is 16.00. Depending on the periodic table, it might rate like 15.9998 or something like that. A lot of times it's rounded to 16.00. But you can use more significant figures. Don't worry about that. So in order to get the molar or molecular mass, the molecular mass of water, we're going to take 2 times the atomic mass of hydrogen and add the atomic mass of oxygen, because there's only 1 oxygen. And when we do that, we get 16.016 AMU, atomic mass units. Or we can round that to 4 significant figures, 2 after the decimal, as 18.0 AMU. Okay, so if we want to do this for magnesium chloride, so magnesium chloride has, remember the formula is right up top there, MgCl2. So that means we need the atomic mass of magnesium and the atomic mass of chlorine, and we are going to multiply the atomic mass of chlorine by 2. So magnesium is 24.305 AMU, and we only need 1 of those. And then we're going to do 2 chlorines. And chlorine's 35.453. AMU. And we're simply going to multiply 35.453 by 2. So 35.453. Multiply that by 2, which is 70.906. And then we're going to add that to 24.305. And we get 95.211 AMU. So the formula mass of MgCl2 is 95.211 AMU. A couple more examples. C6H12O6, glucose. It's covalently bonded together, so we're going to be coming up with the molecular mass. So we need 6 carbons. Carbon is 12.011 AMU. Hydrogen we just saw was 1.008 AMU. And we multiply that by 12 because there's 12 hydrogens. and then oxygen we saw was 16.000. We need to multiply that by 16.00, sorry. We need to multiply it by 6 because there's 6 oxygens in a glucose molecule. Doing the math, 6 times 12.001. Try that again, sorry. 6 times 12.011. And then 12 times 1.008. And then 6 times 16. If we add all that together, we get 180.162 AMU. You can round that to 180.16 if you want, because we only have 2 numbers after the decimal for water or for oxygen. So rounding that to 2 after the decimal is fine. And then let's do the formula mass of aluminum hydrogen phosphate. That's an ionic compound, right? It starts with a metal, so that metal is going to be an ion. So hydrogen phosphate's the anion, aluminum's the cation. So we're going to need an aluminum. So aluminum has a mass of 26.982 AMU plus. So now we can see there are 3 hydrogen phosphates, and each hydrogen phosphate has 2 hydrogens, but we have 3 hydrogen phosphates, so we're going to need 6 hydrogens. So 6 times 1.008 AMU plus we have 3 phosphorus, because there's 1 phosphorus in every hydrogen phosphate, or dihydrogen phosphate, sorry, that's dihydrogen phosphate. There's 1 phosphorus, but we have 3 dihydrogen phosphates, so I need 3 phosphate, or phosphoruses. So there's 3 phosphoruses, so I need phosphorus, which is 30.974. 30.974 because we've got 3 phosphoruses. And then we have 12 oxygens. There's 4 oxygen per dihydrogen phosphate, but we have 3 dihydrogen phosphates, so overall we have 12 oxygens. So basically you can see if you have something in parentheses, we take the value outside the parentheses and multiply it by the number that are inside the parentheses, and we get the total number of that element. So we have 12 oxygens, and that was 16.00 AMU. Okay, doing the math, 26.982 plus, we're going to do 6 times 1.008, 3 times 30.974, and then add 12 times 16. I get 137, or no, sorry, not 100, 317.95 AMU. Wow, that's pretty high. Okay, so that's how we do that. Just take each element and the atomic mass of each element and multiply by the number of that element you have, and the number of atoms of that element you have, and then add them all together. All right. Awesome. Before we go, I'm going to check that last one again. It seems a little high, but it could be right. But I want to check it before I stop the video. 3, 4, and 12 times 16. Yep, 317. That's right. All right. See you in the next one.